All right, well, we're going to skip the minute to win it for right now. I think we're going to take a look at that another day. But we're going to start here by looking at what is direct variation. What is that idea that something changes directly? What does that mean? Well, our goals today is that you can recognize a direct variation relationship and write a function equation for a direct variation equation and in multiple different methods. So let's start here. What is direct variation? It's a relationship between the input. So we talked about input being what letter? We know that's our x. And our output, which is y. It has a non-zero constant. So what that means is you're changing it by the same amount every single time. Okay? Now you can't change it by 0 because then you get the same answer every time. So it has to be non-zero. So it could be 1, it could be -3, it could be any number that's not positive. It even could be decimals. But right now we're going to look in this idea, it just can't be 0. Okay? So it's something that's going to vary directly. So this is what direct variation looks like. This is the generic form of the equation, y equals kx, where k is our constant of variation. Okay? That we can say, okay, this is what it changes y. Now, we've looked at a lot of these as we've walked through our function tables. We've said, okay, if I had 1 and 9 and 2 and 18 and 3 and 27, this is actually a direct variation relationship, that each one of them changes times 9. So y would equal 9x. That's our direct variation, and this would be our constant of variation, times 9. And there are lots of ways to find k. So the first thing we look at, here's our practice problem we're going to try. Does this show direct variation? If I go from our input, which is our x right here, it's always going to be the first number, to our second number, y, do we see a constant change? So how do we get from 2 to 14? You can multiply by 7, or you could add 12. Now, you can't add when it comes to direct variation. You can only multiply. So does it 10 times 7? That's 70. 18 times 7, yep, that's it. 26 times 7, yep, all of those are multiplies by 7. So does this show direct variation? For A, the answer is yes. Does it? If it does it have a direct, a constant of variation? You're right, it does. So you're going to say yes, and we're going to define our variable. We're going to say let x equal hours, and let y equal pay. All right, and so we're going to say y is equal, your pay is equal to 9 times x. Okay? And you'll be able to see how that works out. And then see, since it does not show direct variation, we don't have to answer. It does. Okay? So let's take a look at this idea. I feel like I skipped a page. Did I not? No, I didn't. All right, so one of the ways we can look at this is a function table we've talked about earlier this year, that there are examples of direct variation, and you kind of just saw that on our previous page. So we take the input, the y values, and we talked about this. What is that called? What kind of variables are those called? You guys are right. These are not dependent, independent variables. Okay? I'm going to spell it this time correctly. Maybe not. Maybe not today. Let's try that again. And then the output is called our dependent variable. Dependent. I'm having a really hard time spelling all of a sudden. Let me fix that one more time. Dependent variables. So one of the things it has a lot of different relationships between the two. Okay, so we have between our independent and dependent variable, we have this exact change. So let's take a look at one more. Does this have a direct variation equation? Well, let's take a look at just a couple of them. How do we go from 20 to 8? Well, we can multiply by what? Well, let's think. How can I make it smaller? We'll multiply some kind of fraction, right? So how does that change? So let's kind of do some thinking over here. If this is 8 equals something, let's go k, times 20. So how could I figure out, okay, well, it's just a simple equation. I can solve it, say, okay. So on this case, k is, if I simplify that down, we can both divide it by 4, so I get 2/5. Okay, let's check another easier one. Let's go down to this one down here. We'll skip the decimal one. We'll check that in a second. So let's try it again. So if 10, is that equal to 28 times k? So if we divide by 28, again, this is kind of why I like you guys doing division as fractions. I can simplify. This time I can't divide by 4, but I can divide by 2. So I get 5/14. Are these the same? Since they're not equal to each other. Sorry, it's actually referred to as that. That's not equal to, as are one of our symbols. Put that back up. You can say this is not a direct variation equation. And how do you show it? Well, the constant, that's what we're going to call it, changes. And for it to be a constant, it has to be the same. And since it's not the same, it's not constant. You could check all 4 of these, and they each come out to be a different number. Okay? So by just looking at 2 of them, though, since if it's not the same in all 3, then we're out of luck. All right. So another way to see a constant of variation or to see a graph is it forms a line. That's the first part we know. It's a type of linear function we talked about last unit, but it's a very specific one because it goes through the origin. And the origin is simply 0, 0. It's this point right here. All direct variation equations must go through the origin. Since it's done by multiplication, the only way, if you multiply it, if your input is 0, your output has to be 0. Thank you, zero property of multiplication. So if we look at a problem, does this graph show the constant, a direct variation? You're going to say, first off, you're saying no. A is no. It does not. And you're going to tell me why, because it does not pass through the origin. That's the entire reason. Okay, and this would be something else we would talk about in another lesson if we were talking about slope-intercept form and things like that. So what about this one? Does this show direct variation? You guys figure out A, B, or C, depending on what you have to answer. All right, now that you had a chance to look, you go, yes, it does. And simply because it passes through the origin. Now, we'll talk about the equation in a second. So yes, it passes the origin. Now, the great thing about a graph is you don't really have to define your variables. You already have them defined. X is X, Y is Y. So let's see. If X is 0, Y is 0. If X is 2, Y is 1. So that's an exact point. If X is 4, Y is 2. Now think about that. How can I get that to work out? And I've got to make it multiplication, so it's going to be 1/2 of X. Because half of 2 is 1. Half of 4 is 2. We don't have to remember, just don't have to multiply by a whole number. We can use a fraction as well. So the other way to look at it is the way I showed you at the very beginning, where X is our independent variable, Y is our dependent variable, and K is our constant of proportionality or constant of variation. This is the general form of all direct variation equations. Okay? When we get to our ratios, rates, and proportions, we'll talk about unit rate, and that's going to give us a great connection to it. Okay? So, if we say this, if X makes Y, they vary directly. It's told us in the equation right here. That's the key to the problem right there. Got to read. When X is 10, Y is 40. How can I turn my input into 10, from 10 to 40? Well, I could add 30, but I know direct variation has to be multiplication. So I'm going to say, to do that, Y has to equal 4 times X. So if I plug in 10 here, would I get 40 on the way out? Yep. All right, you guys give this one a try. I have negatives this time. Good luck. All right, again, we see it varies directly, so I know its general form is Y equals KX. If Y is negative 30 and X is negative 3, Y equals 10 times X. All right, so how can I do this? How does K help me on a function table? How does it help me find my missing table charts? Well, I can think the same way we've been talking about all with functions. Because if I go right here, can I figure out what K is from looking at this? Yeah, specifically if I look just at that first term. So Y equals 9X. Now, if I know a couple pieces here, if I know my output is 18, if I know 18 equals 9X, and I solve it, x has to be 2. If 27 equals 9x, what do I have to do? X is equal to 3. If 36 equals 9x, then my input would have been 4. All right, why don't you find this one out? See if this one, if you can figure out. Now, I've given it the opposite way, make it a little simpler. Can you figure out the missing numbers? So this time, we have to look at it. Y equals something x. So if we think about this, let's put this into the equation. We know it's kx. Well, let's see, what do we know? First thing we know is 1 is equal to k times 10. Well, how do we get rid of times 10? We divide by 10. So k is equal to 1/10. So if y equals 1/10 x, can I figure this out? Yep, 1/10 of 30 is 3, 1/10 of 40 is 4, 1/10 of 50 is 5. Why did that work? Because we can use multiplication. Now, a lot of you might have been tempted to write, oh, it's x over 10. And I get that, that's the same idea, but we want to be careful not talking about that idea. Okay, just keeping that in the back of our head. While it's the same, we want to stay with k being an actual number out here. Okay? All right, now, what if there's no table and can we still find the relationship? Yes. Since they vary directly, we have a little bit more information. Since it says this, we know that k is always going to stay the same. So if I go, oh, okay, so if 3 is equal to 12k, how do I get rid of 12? Well, I use my equation rules. And now I got to simplify. So 1/4 equals k. All right, so now if I know y is 5, can I figure out x? Yeah. 1/4 of x. Oh, now how do we get rid of the fraction? Oh, this is just like last unit. We use our reciprocal. We multiply by 4 over 1. So we get 20 is equal to x. There's my answer. All right, your turn to give this one a try. All right, now that you've got it, let's see how you did. So first thing you did is you plugged in the equation. So 60 is equal to 12k. Well, you're going to solve for k. 5 is equal to k. All right, so I've got my k this time, so I'm going to say if y is 6 and k is 5, what's x? So we divide by 5. So what is x? X is 6 over 5. And that's perfectly fine. That's the answer. You could also go in and tell me, hey, Mr. Maloney, it's 1.25. That's the correct answer too. Or not 1.25, 1.2. All right, you've got the, now last one to try. This time I'm gonna give you guys a fraction to work with. So good luck. All right, so first setup on the problem. 4.2 equals 2k. We divide by 2. Oh, this one's actually easier than the last one. K is equal to 2 1/10. So this time, I don't have y, I have x. 2.1 times 7. Y is equal to 14.7. There's my final answer. Now you've had a lot of time to look at how things vary directly. It's your turn to go ahead and practice this on your homework. If you have questions, please come see me in the morning. I'm happy to help you.